This is part 1 of Lesson 7, Unit 8, Volumes Revolving Around Other Axes. So what we're going to do is we are going to look at revolving around a horizontal or vertical line that is not the X or the Y axis. It's still going to be a horizontal or vertical line. So the difference is going to be how do we set up either our disc or our washer, because the radii are going to be different now. So the whole idea is going to be the same, but now we have to take into account that distance. Sometimes the curve will come right up against the line that we're revolving around, and that will make us have a disc. If we have a gap, then we're going to have a washer. So we'll have to take that into account. So let's look at some basic ideas with some general expressions and equations that'll help us get to where we need to go. All right, so to rotate about a horizontal line, and that horizontal line is just going to be some constant, y equals c, we're going to express our outer radius and our inner radius as a function of x and integrate along the x-axis. So the first thing is we're going to write the general form of the volume for the area R, where any cross-section is perpendicular to the axis of revolution. So we're going to have, like we did before with two curves, we're going to have a capital R and a little r, an outer R and an inner R. So in this case, our outer R is going to go the whole way from where we're revolving clear down to the x-axis. And so our outer R is going to be our C. And the inner R is going to be the distance between that line of revolution and where our curve is. So that distance is going to be C, and then we have to subtract from it where this little r hits the curve, which is going to be f of x. So our volume will look like this. V is going to equal, we have our pi times the integral from a to b, because we're going to go along this axis to integrate, and we're going to have c squared, because that's our capital R, minus c minus f of x squared dx. So here is our capital R of x, and here is our little r of x. Okay, so now if that line of revolution is below the x-axis, we're going to have a little different way to set up our outer and inner R. So our little r is now just going to be this distance. It's the shortest distance. So this is our little r here. And that's just going to be just c. That's how long that is. And then our outer r, our big R, is going to go from the curve all the way down to our line of revolution. So capital R is going to equal our f of x plus c. Okay, so our volume will look like this. Pi times the integral from a to b of our outer R, which is f of x plus c squared, minus our c squared, our little r, dx. Okay, so now, what if the curve doesn't touch the axis or the line of revolution? So now we're going to have a capital R and a little r. This is where we're going to create a washer. We're going to have a hole in our figure. So our little r is going to be just this distance between where we're revolving it and the upper curve. It's going to be the smallest distance away from our axis of revolution. So our little r is going to be our c minus our f of x. And our big R is going to be that bigger distance here that we're traveling. So our big R is going to be c minus g of x, because that'll be a longer distance. So then our volume is going to be pi times the integral from a to b of c minus g of x squared, so that'll be the first radius, squared, minus c minus f of x squared. That's our shorter radius squared, dx. And now what we have in this situation is the curve is above the x-axis, but the axis of revolution is below the x-axis. So now we're going to have a distance here for our capital R, which is the longest distance. R is going to equal f of x plus c. And our shorter r is going to be g of x plus c, because we're looking for that distance. Don't worry that c is negative, because we want, so some of the problems it's going to look like we're subtracting a negative, because we want to add that distance. Remember, distance is positive, so that's what we need. Okay, so our volume is going to be pi times the integral from a to b of our big R, which is f of x plus c, squared, minus our little r, which is g of x plus c squared dx. Okay, so now let's do a couple examples with that, and then we'll talk about revolving around the vertical axis of revolution. Okay, so first example we have is y equals the square root of x, the line y equals 0, and x equals 4, and then we're revolving it around the line y equals 4. So first thing you notice is on the graph here, we have the line y equals 4 up here. And so we're going to have a gap, because this is going to go like that. Before we get to the line y equals 4, x equals 4 is right here. Okay, so we have this solid, this area here, that we're going to revolve to make a solid right there. Okay, so we have a big R that's going to go clear from the line y equals 0, which is the x-axis, up to here. And that's going to be just r equals 4. And our little r is going to be just this distance right here between our revolving axis and the curve itself, which is going to be 4 minus the square root of x. So this method is going to be a washer. And so our outer radius is just going to be y equals 4, because we're going to have that little gap there. And our inner radius is 4 minus the square root of x. So v is going to equal pi times the integral from 0 to 4. That's along our x-axis here, of our capital R, which is going to be 4 squared, minus our little r, which is 4 minus the square root of x, squared dx. So we're going to have pi times the integral from 0 to 4 of 16 minus 8 times the square root of x plus x dx. And simplifying this, we get pi times the integral from 0 to 4 of 8 times the square root of x minus x dx. So this is going to be pi times, and then we're going to have our 8, and then we're going to have to multiply it times 2/3, and our x is going to be to the 3/2 power. You're going to have minus 1/2 x squared, evaluated between 0 and 4. So v is going to equal pi times, if I simplify all this and substitute, I get 128 over 3 minus 8. Combining those, subtracting 24/3, I get 104 pi over 3 is my volume. Okay, next example. Now we're revolving around y equals 4 minus x squared, y equals 0, and the line y equals -1. Okay, so drawing this picture, we are going to have a parabola that we're stopping, a parabola that we are stopping at the x-axis, because we have the condition of y equals 0. So it's going to look like this. Okay, and of course, here is our solid that we're revolving, and hopefully you can see that we're again going to have a washer because we have that gap there. So our lengths are going to be, our biggest length is here. Here's our capital R, and R is going to equal y plus 1, which is really just 4 minus x squared plus 1, which is 5 minus x squared. So that's our big R. And our little r is going to be this distance right here, which is just r equals 1. Okay? If you want to be technical with the way the shape looks, it's going to be 0 minus a negative 1, which would just give us the 1. Okay, so we're revolving it around this axis right here. So our volume is going to be pi times the integral, and we want to see where this hits the x-axis, and those 2 points are at -2, 0 and at 2, 0. If you take your function 4 minus x squared and set it equal to 0, you get 4 equals x squared, so x equals plus or minus 2. So you can either do this from -2 to 2, or you can do it 2 times the integral from 0 to 2. So we're going to have 5 minus x squared, squared for our capital R squared, minus 1 squared. This is dx. And I'm just going to do it 2 times pi, 0 to 2, so I don't have to do the lower bound limits. It just makes life a little easier. And so when I expand this, I get 25 minus 10x squared plus x to the 4th minus 1 dx. So this is going to equal 2 pi times the integral from 0 to 2 of 24 minus 10x squared plus x to the 4th dx. So v is going to equal 2 pi times 24x minus 10 thirds x to the 3rd plus 1/5 x to the 5th. And that's evaluated between 0 and 2. So we get 2 pi times 48 minus 80 thirds plus 32 over 5. And I'll leave you to check my arithmetic, but you get v equals 832 pi over 15. So that's the answer for that one. Okay, so I'm going to stop here, and I am going to do the other axis of revolution in the second video.